Do not disturb is on, like it means anything. I put that on my head all the time. Hi, I'm Steve from 1233D. Today we are going to do something a little bit different. This video is going to be aimed at the beginners, or even some seasoned 3D printers might find some of the tips and tricks within this video useful. Basically, we are going to do an in-depth start to finish process from slicing to printing, orientating models, setting temperatures for materials, all of that good stuff. So stay tuned. Okay, right, so what I am going to start off at the very basics. I've opened up Creality Print, as in most part, new beginners especially are drawn towards the Creality machines for a number of reasons. The price point, ease of use and all that type of thing. So I think it will be only fitting that we use a Creality machine, i.e. the High, as our demonstration for this video. The processes that I will go through will be applicable to the K1, K1C, K1 Max, the Ender 3 V3 SE, the KE model and the standard Ender 3 model, across the whole range of pretty much all of the latest modern Creality printers. So without further ado, let us jump in. So I'm going to click on the little drop down box in Creality Print, and I'm going to select the bottom box where it says select stroke remove printer. So I'm going to open that, wait for it to load, and as you can see, it gives us a nice box full of all the printers. Defaultly opens up to the flagship series, which is the K1C, the K1 SE and all of those. We are going to go for the High series, so I will select that one, and then we have the Creality High with a 0.4mm nozzle and a plus button. So if you hover over the plus button, it then opens up another window that gives you different nozzle sizes. This machine is fitted with a 0.4 nozzle, so that is the one that I shall check. So now we've got a little green tick, we'll click confirm. So it's given me basically a set of values here. I am going to discard those values because they are values that I've had set up for another machine. So we're going to start straight from scratch. So now we have a graphical representation of our build plate for the High, as you can see. The first thing that I do is right about here on the right hand side, we've got a little box that will come defaultly set as white, so you'll see it like this. You really want to, no matter how bewildering or intimidating this may appear to be, it really isn't, click it for advanced parameters. That will give you a lot more options to tweak and tune. The next thing that I'm going to do here, I've currently have my printer set up to print ABS, so I will remove that, click on the little box on the drop down. We've then got generic ABS, which I don't want ABS, so I will switch this out now to generic PLA, which is there. Now, just to be aware, one of the questions that I most commonly get asked is, why is my printer not extruding filament? The extruder is making some strange clicking noise. Now, 9 times out of 10, when you first install Creality Print onto your machine and your printer, you will use the Hyper PLA filament that Creality supply with their machines. So defaultly in the slicer, you are set to Hyper PLA. Now, as you can see, currently I've got generic PLA set, and it's given me a nozzle temperature of 220 degrees and a bed temperature of 60 degrees for this machine. So typically, PLA materials, you print in at a high speed, so the material needs to be extruded at a higher temperature to basically keep up with the demand of the printer. So typically, most modern machines that are running Clipper or Clipper variants of firmware need to be printing PLA at around 220 degrees. With this being an open bed, the bed temperature is slightly higher than what it would be on an enclosed printer, so 60 degrees for this instance is absolutely fine. So we've got the material set, we've got our build plate set for the correct printer that we're using, so I guess the next thing to really do is drop in a model. So I shall go onto the little plus icon box, add. I'm going to start off with a very simple hook, which I've downloaded from Printables. The link for that website will be in the description. So I have a little tiny cleat, and at the same time I will add the other part because it's pointless having such a small part on the build plate. So that's instantly dropped that model over my other. I can't now see it. If I click here and across the top menu, arrange all objects, or press A or Shift and A, we can then position those models so they don't conflict with each other. Basically, it's put them in the right places. Next thing that I'm going to talk about briefly is how you orientate your models. This is a very, very critical part of slicing any file. If you imagine you put your model in place, you might think, well, actually, I'm going to stand this upright. So for argument's sake, I'll stand it up. I'll move it over so we can still see the other one. That isn't a drastically bad overhang. You would absolutely get away with printing that. But saying that, there are a couple of flaws. It might be a little bit hard to see, but I will try and highlight it as best as I can. So looking at the base of this model, you can see that we've actually got a hollow recess. That recess is to allow for this part to fit inside. So basically, if you wanted to fit this hook, you screw this part to the wall, then the hook would actually slide and lock into place over it. That is a potential failure point there unless you supported it. Now, you wouldn't really want to add supports into such a small space like that because, one, it would give you a nightmare trying to break them all out and clean it to get an absolute perfect finish. And the second thing that you want to take into account is that the machine is going to print in layers. So by printing in this orientation, you're going to end up with layer lines going up across the print, which gives you potential breakpoints on the load-bearing areas of your print. So that isn't going to be ideal in any way at all. So you might think, well, okay, I'll flip it upside down and I'll have it in that orientation. You've alleviated the problem with the hollow in the bottom and you've now got a flat surface on your build plate, but you've still got the filament orientation going in the wrong direction. The layers are going to be going that way, again, giving you a failure point. If you put anything heavy on this hook, then it could very well break along that type of line. So the best way to place this model would be upon its side, how it was defaultly imported, because that way your layer lines now are traveling across the entirety of the print. So you're going to gain maximum strength from that printed part. That is only part of the story. The other thing to take into account is you want to basically consider how strong you want the part, and a general rule of thumb on how to get to this conclusion will be how many walls you want and how much infill you want. So walls are basically the perimeters that circle outside the print. Perimeters are also your bottom layers and your finished top layers, and then infill is the amount of material that you put in whatever chosen pattern inside the print. Typically for structural parts, I tend to go off a general rule of thumb where I'll use 4 walls, 4 to 5 top and bottom layers, and I will use an infill density of around 50%. So the next thing is I will show you how I achieve that. So here on the right hand side of the screen we've got all the menu, and if we scroll down we've got a whole host of different things that we can tweak, change, play with and whatever else. The first thing, we're set at a 0.2 millimeter layer height, which for this model that is absolutely fine. We're not going to mess with anything there. So then we'll go down to the next one on the menu which says strength. We'll click on that and now we've got another menu that pops up saying wall loops. Defaultly this is set to 2, so we're going to increase that to 4. Now we've got top shell layers. So basically this is this portion of the print, the top layer. Currently it is set to 5. We will drop it down to 4 just for argument's sake. We'll keep it all equal. Then we have shell thickness. We don't need to bother with that. We've got pattern, which I will go into in a little bit more depth in a minute. We'll sort out the actual layer counts first. So bottom shell layers, we've got 3 as default. So we want that to be 4 as well. So what we've done now is we've surrounded the whole outside area of the print with 4 layers of 0.2 millimeter high layers. Absolutely fine. Next up, we'll scroll down that same box to where we get to infill. So we've got sparse infill density defaultly set to 15%. We want to change that to 50. And I also changed the sparse infill pattern. My go-to pattern for anything structural is gyroid. I just find it's the most efficient, strongest type of infill. My personal preference. Again, play around with them. See which ones you like, which ones you find the best for your use case. So that brings me now to top surface pattern and bottom surface pattern. The best way for me to really demonstrate this will be to slice the plate now to give you an absolute representation as to what this does. So I'll slice the plate. As you can see now, I have set monotronic lines on the top. So you've got lines going across in like a diagonal formation. And if I look at the bottom of the print, you've got monotronic, which is very similar. Again, we've just got a series of diagonal lines going across the print. If you're printing on a textured plate, that is absolutely fine, because what you will find is on the bottom of your prints, you will end up with a slight texture, which is a very nice finish. But again, totally dependent on your use case. You might not want that. You might want something a little bit more decorative. On this machine, we've got like a satin type finish. It's not heavily textured, but it's not smooth. So it will give us a very, very supple mottle type finish, if you like. I have found a pattern that is called Hubert Carve.
Bro, what are you talking about, man?
And it's very nice. It takes a little bit longer to print, but it gives you a nice decorative finish on both top and bottom layers. So for this, I'm going to select those. And again, I'm going to slice the plate. And now if I zoom in, you can see that we've basically filled all of this with little tiny, I can only describe it as Tetris type shapes. And again, that has been mirrored on the bottom. Currently, it is saying for this model with that top layer, the amount of infill we've got, the walls and everything else, this print will take us 24 minutes and 43 seconds. So I'll just jump back and give you an idea and slice again. The print time has come down fractionally to 22 minutes and 46 seconds. So these things do increase print time. So if it is something to take into consideration when you're choosing what sort of pattern and everything else that you want. That is the basics for slicing a model in this orientation, the reasons why you would place it in the way that we have done, the reason why we've selected the wall count and all of that stuff. This is ultimately a hook. So you're going to hang your coats and whatever on it. If it's a wet coat, you want it quite strong because it's going to be quite heavy. And if you didn't print it with adequate infill or walls, it could potentially break. So you've beefed it up, you've added quite a bit of infill. And again, I'll use a slider so we can actually demonstrate how much infill we have inside that print. As you can see, it's quite dense. So this is going to be absolutely fine for the use case that we are going to want to use it for. So what we would then do is we would send the print to the printer. And you can simply do that by selecting send print. Now, I haven't actually got the printer plugged in and connected up to the Wi-Fi yet. If I had this machine, I would have already hooked up to the slicer. So it would send the slice file directly from the computer over Wi-Fi to the printer. We could either have two options to send and print or send file only. So that means that you can send and print as provided your printer has got filament loaded and there is nothing left on your build plate. You're absolutely good to do that. Otherwise, just send the file, check the printer, make sure it's ready to go, then go into the printer user interface and select the file and press print from there. You're golden. So that's the first model that I will demonstrate on. So I'm going to jump back to prepare and we will load in another one. So highlight those, just simply delete, and then we'll jump back onto the add. Next, a little T-Rex. Now, the reason we picked this is there is parts of this model that, as you can see, not touching the build plate, i.e. the tail for starters, the actual arms and his lower portion. So the only parts that actually are touching the plate of this model are his feet. Now, typically, people may just well go ahead and slice this file. We've set all those settings up. So we've got 4 walls. We've got all of that jazz that we did in the previous model, but the print would fail. And the reason the print would fail is because we haven't added any supports to the print. We'll drop down to the next box down below speed. We have one called support. Typically, we have type. So it's set defaultly to tree supports. We have style, which is on default. We have the angle, all of that stuff. All we need to do is, for this model, we can have prints supports from the build plate only. So we'll check. Why will it not let me check it? Ah, okay. We have a broken file. This file, unbeknown to me, has an error. Down here in the left-hand corner, as you can see. Good use case, because occasionally this does happen. So object name T-Rex STL has an error 24, non-manifold edges. What we can do is simply click on repair. Now Creality Print is going through and it will basically fix this model, hopefully. It might take a little bit of time. It's got to basically analyze it, work out what the fault is, how it's going to fix it. We should be then good to go. That error should just disappear once it has done that. So please bear with me.
Eventually.
Okay, so we have now repaired. We've got another little notification saying the following model object has been repaired. So we can now close down those boxes and you can see we can now enable supports. Defaultly set to tree, style is on default, so we have different options here. We can go to slim tree, strong tree, tree hybrid or organic. For the purposes of this, it's not a big model. Slim tree will be absolutely fine. So it's given us, we have an experimental style of slim tree. No, we don't want to mess around with that. We'll keep it as it is. We have the angle, which we can change. You don't really need to tweak with that at the moment. And then we have the option to basically add supports from the build plate only. That is the preferred method, because then you don't have support material printing on top of your print. It will only print from the build plate up to support the areas that it needs to on your print. So for this model, I am going to check that. I've got raft layers. We don't need raft. Nothing else really on there that we need to change at this point. We'll go to skirt and brim. So the bottom one, which comes under others, we have the first option, which is skirt. Now a skirt will basically print a purge line effectively, however many lines that you tell it to around the model. We don't need that. We have a brim. Now, for this model, we've got a relatively low amount of surface area for quite a large model in contact with the build plate. Now, most failures occur because a model will become detached from the build plate during printing. This can end up in a whole host of different messes. One, you could end up with a model stuck to your nozzle, and if you're not monitoring the printer, left unattended, this then clogs the nozzle, causes a massive blob of death, as it's known, basically encapsulates the whole hot end and destroys it, to the point, in some cases, it can even break wiring and whatever else, which will not give you a good time at all. Other cases, you might get away with that. It might knock the model out of the way and you end up coming back to a build plate full of spaghetti. In all cases, it's very frustrating because 3D printing isn't quick. So you feel that you've wasted a lot of time, you've wasted material and all of that stuff. So my recommendation for this would be, we want to add a brim. I'm going to put outer brim only because that's all we need. Now we've got a brim width. It's defaultly set to 5mm. We will slice the model so you can get a representation of what that looks like. And if I think we need to increase it, then we'll come back and we'll increase it. Because this isn't now a functional part, this is only a decorative item, i.e. an ornament. We don't need it as strong as we previously put it in the settings for our hook. So we can basically lower these down to 3. We can drop our infill down to around 15% is probably overkill, but I'll drop it to 15. And I don't really think, apart from that at this minute, there is much more to do. So what we will do just to see, and we'll check everything's right and we're happy with it before we send it to print, we'll slice the file. This time it'll take a little bit longer because the actual slicing software is now calculating where we need to put supports and what it needs to do and whatever else. So as you can see, we now have a very odd looking dinosaur. The actual model that we're printing is highlighted in orange and all of the support material is highlighted in green. So you can already see that it's supported all underneath the tail. It's supported under his arms, under his chin, up to his mouth. If we just like scroll the slidey wheel down, you can see what that looks like from above. So what that will do is that will print that support structure basically in place to hold the model while it's being printed. Once the print is finished, you remove the print from the build plate with the supports and just gently take your time and break off the support material, leaving your model. If you look at his feet, you can see that they're highlighted with a blue ring around them. So that's the brim. We've basically made his feet footprint bigger. So we've got more surface area to stick to the build plate, helping us give as much possibility of success as we could hope for. So you could increase that if you felt that wasn't wide enough by increasing it from 5mm to 10mm, whatever you see fit. This will increase your print time, and this will also increase your material amount, because obviously now we're printing the material, support material, brim, all of that, which is effectively waste. So that's just something to take into account when you are doing this. For the brim, they remove really, really easily once the print's finished. They're pretty much the same way as you remove your support. So you just peel that away from the feet when you're cleaning up the model. Then you've got your actual finished model. We will put pictures of these models on the video round about now, and we will show demonstrations of a supported model and a non-supported model so you can see what actually happens if you don't do what we're suggesting that you do, just to give you an insight into if you encounter a problem. It should hopefully help you to identify what you can do to prevent that problem from occurring. In not all instances is it the printer, it is something simply that has been missed or overlooked within the slicing software. So again, if you're ready to print, you're happy with that, you would then send to your printer. So next up, we have another one. So I shall get rid of that. Now, this one is aimed for you guys who want to print all the fun things like cosplay props, helmets, that type of thing. Here we found a very, very generic face mask. Now, as you can see, it's dropped it on the build plate in a pretty good orientation, to be perfectly fair. Now, you might be looking at that thinking, how on earth does this print like that? Well, in simple terms, if the machine was big enough to allow you to print this flat, you would end up with really ugly layer lines across the forehead, the nose, the chin, and whatever else that don't really look great and would give you a harder time basically post-processing the print ready for painting or whatever else. So you're going to have more sanding, more filling, stuff that you don't really want to be doing. You want to try and alleviate as much of that as you can in the print, and you do that very simply again by orientating the print correctly. Now, I'm not going to change anything. I'm just going to slice it and let you see what I mean by that. And just do its thing while it's just generating its supports again. Okay, so looking at this now, you can see, I'll go from the back. Our layers are going to be printed in lines like this until they get all the way up to the top. And then you'll have, if I zoom right in, you can see where the layers build up. So you'll have like accentuated layer lines here because it's basically reaching its final point. On the top lip, you can see again, on the bottom of the bottom lip, and on the chin. So that wouldn't be at all bad because pretty much all of those areas are small areas and they're going to be very easy to knock out with a sander if you needed to, or fill, or if you're happy, you probably wouldn't even really notice them because they're in a down position, so you're not smacking your face when you're looking at it. But if we went back and we orientate the model in a different way, which I shall show you now. So I'll go and rotate this. I'll have to spin it round because that will not fit on this machine. Like so. So next up, I shall slice the plate, and now you'll be able to see what I'm talking about. It's got a lot of calculating to do. Come on, you can do it. There we go. Right, so straight away, if you're looking face down, you can see these big red parts, which are, zoom in, they are your accentuated layer lines. So these will be really, really pronounced and visible now on your print. So just by simply tipping the model back, which you would think would then lower your print time or whatever else, which it will do because you're not printing up as high, you are getting not so nice as a finish. So in the ideal world, I would, and I tend to, always stand helmets, face plates, whatever else up, and I will show you how I typically orientate them. So I will go back to move. Actually, I won't. I will rotate around to the way that I want it. So I would stand that facing forward on the plate. I would then come here and I would tilt forwards. So what I've got at that point in time is something that is like pretty much vertical. So if I click on the left side to get a better view, with something like this, I wouldn't really want any supports to be on the outside face. If I was going to support it anywhere, I want those supports to be on the inside face, because that's any scarring that's going to be left behind is not going to be visible on the inside. So that is what I would choose in this instance. So I will simply tilt the model back. We've gone there a fractional amount. I mean, it's not huge at all. I would then check it on the face, make sure I'm happy with where we got. Where's it gone? It's gone. Let's undo that. So if you do make a mistake, those at the top, you can click to undo so you haven't lost it, which I've just lost it again. Don't know why it keeps disappearing, but it does. So I'll get back to the rotate tool and I will just make sure that it's as square as possible. It doesn't have to be perfect, but visually just try and get it as, as close as you can. So I've put the model facing forward. Now, the reason I've done that, if I turn it the other way, it'll be facing this way down the build plate, which means the bed's got more movement to travel in whilst printing. Now that can cause a couple of issues. This is quite a tall print, so you want really to keep this movement as minimal as possible, because any accentuated movement of the bed backwards and forwards when you're printing at a fast speed will give a negative impact on your print quality, because ultimately the print's going to wobble no matter how well you support it or whatever. So if you try and think about this when you're actually slicing your files and orientating your prints, then that will show later on down the line when you actually get the finished print. So again, we've got currently all of my parameters are set. We've got the supports set to threshold angle of 30 degrees. So what I'm going to do here, supports will be generated for overhangs whose slope angle is below this threshold. So 30 degrees default, we will up that and see what happens. So I'll go to 45 degrees, which I think this machine is quite capable of handling. But again, if you're not confident with this or you're not sure, you can leave it as default. It won't have any negative impact on your print. It'll just mean that it'll print maybe slightly denser supports or more supports than you do actually need. So you can leave it on default, you can change it. I'll slice the plate and see how it looks. It's actually slicing a little bit quicker now because I've stood it up. It doesn't need to really calculate as many supports. So as you can see, we look like we have some really strange gooey stuff leaking from our person's nose, which would be supports. The eyes are being supported. If you look at the base of the print, it's done a very clever trick. So it's basically given us a really nice footprint all the way around the base of the print to make sure that the mask is held down to the plate, and those uneven areas are now supported. So there's going to be no issues there. Inside is supported the back of the lip, which is good. And we've got these nice structures going up here supporting the top eyelids. And we've also got a couple here basically supporting the back edge. So the other thing to note is those little nasty, horrible red lines that we had on the previous way that I orientated it were quite pronounced. Here, they have gone, because effectively, the only places now that you're going to have layers that are visible are on this top edge. And look at the print time. We have slashed it from 11 hours to 7 hours. So that is a quite dramatic improvement on the print time. And that will also have a knock-on effect to the actual filament waste as well. So I would have no problems whatsoever with sending this print to print as sliced as is, as we will demonstrate on this machine. We will send all of these files over in the orientations that I have placed them in, so you guys can see what impact different positions and settings has on the prints that we do. And then hopefully that will give you the insight to be able to go away, look at what I've shown you here across these 3 models that we've used, and implement these into your own models and give you a better experience slicing and printing successfully. The other thing to mention would be the infill pattern. Typically, as default, Creality Print comes with the infill pattern defaultly set to grid. Now, throughout our time, we've seen a number of different people complaining about grid. Some people have no issues at all. Other people have huge issues with grid infill. I think a lot of it comes down to the actual machine that you're printing on. But effectively what happens is, if you print grid infill, in some cases, as the nozzle passes back across the print, it actually grates on the grid infill. Now this isn't ideal in any circumstances, because what can happen is, one, you can actually knock your print clean off the bed, which you don't want to happen. Two, you can distort the actual print, so the print quality suffers because of it. I'm not sure why this is. There are settings that you can change, i.e. your Z-hop and whatever else. You can make the nozzle travel higher to clear the print as it travels and then come back down. Some cases that's an ideal fix. Again, it's all hidden within the settings of your slicing software and things that you can play around with should you need to. But typically, gyroid, I haven't had any problems with. The other people swear by all different kinds. I mean, Chris, I know in occasions when he's wanting to print something quite quickly, that isn't really structural. He's printing it with lightning, because what that'll do is it'll basically print out lightning branches inside the print, so it's using minimal material to actually support the inside of your print. Prints really, really quickly, works well for a decorative ornamental piece that isn't going to get any use or wear. So again, scroll through them, drop a file in, play with all the different settings, see which one you like, try some, experiment. You know, ultimately guys, that is how you learn. Play with it. You can always undo icon next to it to put it back to default. You're not going to break anything. You know, it's really that easy. You don't learn unless you try. The best way to try with this, before you send it to print, slice it, mess with the settings, see what it looks like on the screen, like I showed you by the slider bar. That will give you a pretty good idea what the finished item is going to look like when you print it. We do have a couple of sites where we always regularly use for models. One is Prusa Printables, which is a well-known website. The other one is MakerWorld. Thingiverse is still about. You can also then go on to Cults. You could even go to Etsy and you can buy STL files from Etsy. So there's a whole host of different sites that are available for you to actually go and get your files from to print. And you can join Patreons and all manner of different things. The only thing that I will suggest that you do check out is the actual Creative Commons licenses. If you're planning on printing things to sell at craft fairs or whatever, make sure that you have permission via the license to do so, and you can find that information on the actual file when you're on the website. So just check it out, have a look at it. Creative Commons license. We'll even put a link to the logos and whatever else in the video so you know what I'm talking about. There's no hard and fast way to do this. It does come with experience. I hope some of the experience that I've gained over the years that I've been doing this for has helped you and giving you a bit of insight. Anybody here is looking at starting 3D printing, or is interested in starting 3D printing, or is just considering it, please check out the link in the description to our website. Have a good look through there. If you want any advice or you're not sure, give us a call, drop us an email, link in the description. If you haven't already, please do not forget to like, subscribe, and maybe even share, as it helps the algorithm. I hope you've enjoyed this video, and we will see you on the next one. Bye bye for now.
As always, we aim to have the most competitive 3D printer prices on the market. If you see any of our printers being sold by a mainstream retailer for less, please drop us an email using the link in the description and we'll do our very best to beat their price. Also, if you're watching from outside the UK, check the description for links to our European 123 3D sister stores.